Hello viewers, I'm Kausalya. Today we are going to solve problem 9 and 10 in exercise 7.1 in the chapter Coordinate Geometry. So problem number 9, if Q of 0, 1 is equidistant from P of 5, minus 3 and R of x, 6. So here we have 2 points P and R, right? And these 2 points are equidistant to the point Q, right? So you see, this is point P, which is 5, minus 3, and this is point R, x, 6. These 2 points are equidistant from this point Q, right? What do you mean by equidistant? That is, the distance PQ is equal to RQ, right? Also find the distance QR and PR. We have to find the value of QR and as well as PR, right? So, as usual, here we are going to make use of the distance formula. So, here the distance between, that is PQ is equal to RQ, right? This is given in the problem. So, just we are going to substitute the terms. So, first I am considering PQ. So, the values of P gives x1, y1 and Q gives x2, y2. So, square root of x2 minus x1. So, 0 minus 5 the whole square plus 1 minus of minus 3 the whole square. Right, this is what written here. Again, when you consider the points R and Q, R gives x1, y1 and Q gives x2 and y2. So, x2 minus x1, 0 minus x the whole square plus 1 minus 6 the whole square, right? So, once you substitute the values here, you see, the next thing is I am squaring on both sides in order to remove the square root, right? Or else you can directly write it as PQ square equal to RQ square. When you write square over here, you can write this formula without the square root, right? So, squaring on both sides removes the square root. Now, the remaining terms you see minus 5 square. 0 minus 5 is nothing but minus 5. So, minus 5 square becomes 5 square or else 25. And here 1 minus of minus 3. So, minus into minus becomes plus. So, 1 plus 3 the whole square. And again here 0 minus x square gives x square and 1 minus 6 is nothing but minus 5 the whole square. Right. Now we are going to simplify the terms. So here 5 square is 25 and 1 plus 3 is 4. So 4 square. And here it is x square plus minus 5 square also gives the same 25. So 25, 25 they get cancelled and the remaining terms are 4 square is equal to x square, right? So x is nothing but plus or minus square root of 4 square. So the square root and the square get cancelled. So the remaining terms are finally plus or minus 4. Therefore, the value of x is plus 4 or minus 4. Right. So here we are considering the case 1. First, I am taking the value of x as 4 and I am going to calculate the distance RQ. Right. So this is my R. The value of R is x, 6. Right. So first I am taking the value of x as 4. So 4, 6 and Q is 0, 1. Now again by using the distance formula, I am going to calculate the value of RQ. So 0 minus 4 the whole square plus 1 minus 6 the whole square. So that gives the value of 16 and here 5 square gives 25. So the answer is square root of 41. And the next thing is PR. Right, again the value of P is 5, minus 3 and what about R? R is 4, 6. Again by using the distance formula, we are going to calculate the value of PR. So 4 minus 5 the whole square plus 6 minus of minus 3 the whole square. So 4 minus 5 is minus 1 and minus of minus becomes plus. So 6 plus 3 is 9 square. So minus 1 square is 1 and 9 square is 81. So 81 plus 1 gives you square root of 82. Now we are considering the value of x as minus 4. Right. So again the value of Q is 0, 1 and the value of R is minus 4, 6 because here we are taking the value of x as minus 4. So again the same formula minus 4 minus 0 the whole square plus 6 minus 1 the whole square. So minus 4 whole square, that is minus 4 minus 0 is minus 4 again. So minus 4 square and 6 minus 1 is 5. Right, 5 square. So 4 square is 16 and 5 square is 25. When you add, finally you got the answer as root of 41. Okay, this is my distance QR when the value of x is minus 4. Next, we are going to find the value of PR. So here PR, again take the 2 points P and R, and P is 5 comma minus 3 and R is minus 4 comma 6. So again minus 4 minus 5 the whole square plus 6 minus of minus 3 the whole square. So minus 4 minus 5 is minus 9, and you see 6 minus of minus 3. So minus of minus becomes plus. So 6 plus 3 is 9. So minus 9 square is 81, and again 9 square is 81, and finally the distance PR is square root of 162. Right. So here we have calculated the value of x, and again we have calculated the value of distance QR and PR for different values of x. Right. Now we proceed with our last problem of this exercise. Find a relation between x and y such that the point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. So in the previous solved problems, any one thing will be missing, right? Either among these x and y, one value will be given and one will be unknown. Or in other words, this point will be given, and in these 2 points, any one term will be missing, we will be calculating, right? Here also the same thing, but here you see, here 2 unknown terms are there, x and y. That's the reason here the question is you have to find a relation between x and y, right? That is the difference, but everything remains the same. So again you see, this point is equidistant from these 2 points, right? So this point, let this point be O, x comma y, and this is A 3 comma 6 and B minus 3 comma 4, right? So OA is equal to OB. This is clearly given in the problem, right? Equidistant. So now we are going to substitute the values. So OA, OB, and again O is x comma y, right? This gives x1, y1, and A gives x2, y2. Similarly, here O gives x1, y1, and B gives x2 and y2. Now we are going to substitute these terms in the formula. So again 3 minus x the whole square plus 6 minus y the whole square. And here it is minus 3 minus x the whole square plus 4 minus y the whole square, right? So squaring on both sides, this removes the square root. So the terms are 3 minus x square plus 6 minus y square. And here it is, you see I have minus as common term. So when I take minus outside, this becomes 3 plus x the whole square plus here 4 minus y square, right? So again we are expanding this using the formula a minus b whole square, and here it is a plus b the whole square. So a square it is 9 and b square is x square minus 2ab. So 2 into 3 into x, that gives 6x. And here again a square 36, b square y square 2ab. So 2 into 6 into y, that is minus 12y. Right, you see here minus square. So whenever a minus is squared, it becomes plus. So simply we can ignore this, and again we are expanding this using the formula a plus b whole square. So a square is 9 and b square is x square plus 2ab. So 2 into 3 into x, that gives 6x. Right, again here a minus b whole square. So a square is 16, b square is y square minus 2ab, 2 into 4 into y, which is minus 8y. Right. Now we are going to cancel out the common terms. You see here I have 9 and here also 9 with the same sign. Okay, that is most important. So I am cancelling 9. Next I am cancelling the x square, and next I am cancelling y square. Right. Now I am going to move all these terms to the single side. I am moving these elements to the left hand side. So you see minus 6x, right, minus 12y plus 36. And here this plus 6x when moved here, it becomes minus 6x minus 16, and this minus 8y becomes plus 8y equal to 0. Now I am going to combine x terms together, y terms together, and the numbers together. So minus 6x becomes minus 12x. and minus 12y plus 8y. So minus 12 plus 8 becomes minus 4y. Right, and 36 minus 16 gives 20. So you see, when you look at all the terms 12, 4, 20, all these terms are divisible by 4, right? So we can divide the entire equation by 4. So what happens? Minus 3x minus y plus 5 equal to 0, right? 12 by 3, 4, 12 by 4, 3, 4 by 4, 1, 20 by 4, 5, right? So, and finally, when you rewrite, you see 5 is equal to, when I move these two terms to the right hand side, they become positive, right? 3x plus y. And finally, the equation, the relationship between x and y is given by 3x plus y. I am moving this plus 5 over here. So, minus 5 equal to 0. So, this is the relationship between x and y for the given problem. Right. So, that's all in this video. If you have any doubt, let me know in the comment section. Thank you.